Hello and namaste to all of you. Today in UPSC GS series, we are doing under sustainable development the unit 14 harness technology. In audio number 20, we have covered harness technology by the industry, and in this audio number 21, we will do natural resources, that is energy, water, conservation of ecosystems, harnessing technology, the Asian context, and summary of the harness technology unit 14 of sustainable development. The general instruction for students are the same, that they have to listen the audio very carefully and note down 10 words from this audio number 21, and by intuition they think that what the meaning of these words and how it is useful to live sustainable lifestyle. Point 6, natural resources. Natural resources like energy, water, and other raw materials like minerals are limited, while some like coal, petroleum, and groundwater are non replenishable. Therefore, strong efforts are needed to use them in a judicious and sustainable way. 6.1, Energy. Energy provides services for human life: heat for cooking, warmth, manufacturing, and power for transport and mechanical work. The primary sources of energy are: number A, fossil fuels like coal and petroleum; number B, wood and charcoal; number C, natural resources like water, solar and wind and natural gas; and number D, nuclear. Coal and petroleum, coal and petroleum are non-renewable energy sources. The energy is converted into services by equipments like motors, turbines, etc. A lot of primary energy is wasted due to inefficient design or running of the equipments. More energy, like electricity, is wasted while transportation, and still more is wasted in the consumer sector due to appliances that are inefficient in utilizing the energy to the optimum levels. The intervention of engineering technology is essential in developing fuel efficient systems to minimize the gross wastage of valuable energy. Burning of fossil fuels has caused an increase in the harmful gases called greenhouse gases. These are carbon dioxide, sulfur dioxide, nitrogen oxide, and carbon monoxide. These gases trap the solar radiation in the Earth's atmosphere, and as a result, the radiation cannot escape. The Earth warms up as a result. This phenomenon is called global warming. Global warming has many detrimental effects on the Earth, like melting of ice caps, glaciers, and raising the sea levels. This has an adverse effect on the species breeding and survival. Besides, these gases combine with the atmospheric water to produce nitric acid and sulfuric acid that come down as acid rain. Acid rain has caused havoc in the aquatic systems in Europe. The pH of the water, which is normally around 7, which sustains life, reduces to around 2 to 3. Aquatic organisms like fishes, etc., die due to the acidification of water. Alternative sources of energy that cause minimal damage to the environment is the requirement of the day. Due to the changes in technology, the US has moved from wood to coal to oil and now to natural gas. With more advances in technology, it would be possible to move on to safer energy sources with low carbon and non-fossil fuels. non-polluting renewable sources of energy like hydroelectricity, solar power, natural gas, and nuclear energy are looked upon as potential sources in the near future. Fuels with higher hydrogen to carbon ratio like methane or ethanol are being investigated and are in the use in some of the developed countries. The automobile industry is developing vehicles that have high fuel efficiency and are far less polluting than current automobiles. In an attempt to switch from environment degrading chemicals to environment friendly chemicals, the industries are taking help from biotechnology. For example, the paper industry used chemicals like chlorine for pulping and bleaching operations. The search for an alternative pulping and bleaching agent led to enzymes called cellulose free gelycolysis. These enzymes are now produced on a commercial scale and are in regular use in developed nations. Some of the other industrial enzymes are those used in winemaking, baking, dairy products, fruit juice, clarification, starch modification, leather, sugar, and confectionery, fructose production, detergent formulation, amino acid synthesis, and designing cotton. Polymers derived from chemicals are difficult to dispose as they do not degrade. Therefore, biotechnology, polymer science, and engineering have come up with a new compound called biopolymers. Biopolymers are synthesized by microorganisms. Some examples are polyhydroxy alkanoates, biocomposites, and polymers of lactic acid. They find use in medicine like suture, prosthetic implants, and agricultural applications like controlled release of fertilizers, fishing nets, and packaging materials. Biopolymers are also used for insulation, conduction, and have other industrial uses like tapes and adhesives. 6.2 Water. Water is one of the most crucial natural resources. Life on earth depends upon water. The sources of water may be divided into number 1 surface water, number 2 groundwater. Surface water consists of rivers, streams, lakes, etc., while underground water consists of wells and springs. Other untapped water resources are snow and ice fields. The hydrological cycle is responsible for the movement of oceans to the land. Large scale evaporation from the oceans results in rain bearing clouds that travel thousands of kilometers of lands and precipitate. This is the basic source of fresh water on land. Melting of snow and ice glaciers also replenish rivers. The sustainable use of water should require that the hydrological cycle be not disrupted. There is evidence that large scale deforestation causes serious disruption in rainfall patterns. The removal of vegetative cover in catchment areas causes floods and droughts. Man's activities have disrupted the hydrological cycle and contaminated both the surface and groundwater sources. Acid rain is the cause of atmospheric pollution, and the repercussions are for everyone to see. Vast forest areas in Europe and North America are damaged by acid rain. Large tracts of soil have lost their productivity. Water is also polluted by other activities on the earth. Industrial waste Untreated sewage and agricultural runoff are major causes of water pollution in the rivers, streams, and lakes. Such waters become unfit for most human uses. Besides, the aquatic life is also severely severely compromised in these ecosystems. Polluted water also poses threat to, threat to human health. It is estimated that 10,000 children die every day in India due to water related diseases. Pre-treatment of industrial wastes and sewage before discharging the water into water bodies is important. The, the industries are strictly instructed to pre-treat their wastes before discharging. For example, acids are neutralized with alkali, etc. The wastewater treatment plants are equipped to treat the polluted water through various steps and disinfect the effluents before discharging. In the primary step, physical methods are used to remove solid materials like sticks, trash, small objects, and stones. The water is then allowed to stand and the suspended solids are allowed to settle. The water is then allowed to move on to another tank where microorganisms are utilized to digest soluble substances in the secondary state. After sedimentation, the water moves into another tank where a specialized treatment removes phosphorus, nitrogen, and other contaminants through advanced processes. The water is then disinfected and recycled. The recycling of the household grey water, all wastewater generated in the house except sewage, is recommended. This water can be used for cooling, ornamental fountains, fire, firefighting, irrigation of golf courses, roadside plants and parks, creation of artificial wetlands and groundwater recharge. To clean up contaminated groundwater, the following technique is used. Tons of iron fillings are mixed with sand and are installed underground in such a way that the contaminated groundwater must flow through it. The pollutants react with iron. Trichloroethylene is a common groundwater contaminant that is effectively treated. Once, once past the barrier, the remediated water continues on its course. 6.3 Conservation of ecosystems. The survival of all species on this earth is directly or indirectly dependent on the other species and also on the non-living components of the environment like air, water and soil. Therefore, if a species becomes extinct, then it affects the survival of all other species. Conservation of natural resources, living and non-living, is therefore extremely important. Number 1. Species conservation. Living beings may be classified into plants, animals, and microorganisms. These, these myriads of species with their genetic diversity play an important role in the process of development and contribute immensely to the agriculture, medicine, and industry. Survival of the species would ensure new and improved foods, new drugs and medicines, and new raw materials for the industry. However, due to the exploitative human interference, species are disappearing at an alarming rate. Races and varieties within the species are also disappearing. Several efforts have been done to conserve the threatened and endangered species by access to methods in repositories. Gene banks have been established with technological expertise like tissue culture, cryopreservation, etc., that ensure propagation, maintenance, and conservation of rare species. Number two, ecosystem conservation. Tropical rainforests are the richest in genetic diversity and also the most threatened ecosystems due to the interference of man. Arid and semi-arid regions are rich in adaptable species and due to harsh conditions produce valuable, valuable biochemicals like liquid wax and natural rubber. Many of the plant species in these regions are threatened. Coral reefs in marine ecosystems harbor a treasure of genetic diversity in their 400,000 square kilometers. The species living in coral reefs generate toxins that are valuable to modern medicine. Depletion of the coral reefs, if allowed to continue at this rate, would mean an irreparable loss. Conservation of ecosystems in situ is a daunting task and requires the cooperation of all nations. Protection of forests and establishment of national parks and sanctuaries are vital. In India, successful attempts have been made to recover the dwindling population of Royal Bengal tigers in the Sundarbans, the lions of Gir forests, and elephants of the Nilgiris. The extensive study and mapping of the ecosystems is an extremely important step towards their conservation. The advanced computer technology combined with geographical information systems, satellite imagery, remote sensing, and aerial photography are used to map and collect vital information about land use patterns and natural resources of the area of interest. The data generated are utilized by analysts to predict weather patterns and global climate changes. Information technology and the internet technology are extensively used by the analysts and experts to exchange data and information worldwide. This information can be translated to specific local areas and necessary steps may be taken based on the data and recommendations of the experts. Point 7. Harnessing technology, the Asian context. Biotechnology, information technology, and material sciences are the three technologies that predominate the development scenario of Asia today. In the 1960s, the Asian food security was addressed with improved varieties of rice and wheat. Agricultural technology coupled with better crop management practices ushered in the Green Revolution where the food grain production increased manifold. With the entry of biotechnology in agriculture, the yield and other attributes of the food grains like resistance to pests and diseases etc. was increased. Countries like China, Japan, India and Bangladesh have attained self-sufficiency in food grain production following the Green Revolution. The advent of information technology with the development of specific customized software packages and the internet has brought an information revolution in Asia. Countries like India, Pakistan, Japan and China have a growing software industry which is the basis of many vital software based applications that are also widely used in the developed countries. Coupled with telecommunications, information technology has brought the common people in contact with the mainstream policy makers and the experts. As a result, knowledge and information flow in all areas has increased tremendously. With the increase in general awareness, public participation has increased for the understanding and elevation and elevation of the various problems associated with sustainable development. The microelectronics industry of Japan and China has had a tremendous impact in generating employment besides using the resources sustainably. The products developed are multi-purpose, customized and environment friendly. Traditional and indigenous technologies have been always predominant in the Asian cultures. Agricultural methods like organic farming, housing made of natural products, sacred groups, conserving important medicinal plants, rainwater harvesting, and biogas generation from waste are all examples of indigenous technologies used traditionally, discussed in detail in next unit. These technologies have been found to be sustainable in the long run. Efforts, therefore, should be made to innovate these culture based indigenous technologies and incorporate them into the social milieu. Summary of the harness technology. The experience of the industrialized nations shows that technology has played a very important role in increasing the production levels. This increased level of production has in turn contributed to the socio-economic prosperity of the developed countries. In the process of development, however, there has been a severe onslaught on the environment that has posed a threat to the human survival. Therefore, the idea that the technology which has been detrimental itself should be modified and used for the developmental process in a sustainable way has been floated. The concept of harnessing technology for sustainable development is gaining favorable response all over the world as people are becoming more and more aware of the problems related to the degradation of the environment that we live in. The existing technologies developed by the Western world have helped tremendously in uplifting the human standard of living. However, these technologies are not far reaching and the developing countries, exemplary Gratia in Asia, especially the rural community, are deprived of the benefits due to bad connectivity, lack of communications, knowledge and information, inefficient transfer and implementation of technology, and unacceptance of the technology by the local environment. The three recently developed technologies in the field of biotechnology, information technology, and material sciences have ushered in a new era of development in the developing countries. The Asian countries have developed small industries based on these technologies that promise to generate employment, thereby uplifting the socio-economic status of the population and provide them with a better standard of living. Agricultural and industrial biotechnology together, besides increasing the productivity in a sustainable way, has the potential to generate millions of jobs for the rural poor. Information technology coupled with the internet has a major role to play in connecting common people with the mainstream. This increases the exchange of knowledge and information and generates awareness about various pertinent issues. Material sciences have generated new forms of biopolymers that are eco-friendly. Together with microelectronics, they have boosted the economy of several nations like Japan, Korea, and China. The products are customized, eco-friendly, and multi-purpose in use. The indigenous technologies based on traditional knowledge have been proved to be sustainable. Therefore, they should given due recognition as they conform to the local environment. In fact, new innovations in Asian and other developing countries should be based on the traditional knowledge and should be implemented in the local environment. Together with other technologies, these indigenous these Indigenously developed technologies will then help in boosting the process of sustainable development. Unit 15, Innovative Practices. Point 1, Introduction. Point 2, Innovation and Industry. Point 3, Recycling and Reuse. Point 4, Innovative Practices in Agriculture and Forestry. 4.1 is biotechnology and agriculture. Under this, point 4, innovative practices in agriculture and forestry. 4.2 is agroforestry. 4.3 is ethnoforestry. Point 5 is community participation, clusters, villages, village cooperatives, bio villages or eco villages. Point 6 is water and energy, that is rainwater harvesting, indigenous water tapping systems, alternative sources of energy. Point 7 is information and communication technology, and at the last, summary of the innovative practices, unit 15 of sustainable development. Introduction. Innovation means the development of a new idea and implementing the established ways of doing things for common use. A new technical idea is incorporated into a commercial product or purpose or process and is put in the market. Historically, such technological innovations have occurred in five waves that has changed in the society. The first wave was from 1780 to 1840, involving iron and cotton textiles. The second wave from 1840 to 1890 involved coal, steam engines, machine tools and railways, iron. The third wave is 1890 to 1940 involved steel, electricity, engineering, chemicals and railways steel. The fourth wave from 1940 to 1990 used oil, automobiles, petrochemicals, aircraft and roads. With the increasing awareness of the community, world community towards the deteriorating environment, search has begun for technologies that are sustainable and compatible with development. From 1990s, we are experiencing the fifth technology wave that involves microelectronics, information technology, telecommunications, biotechnology, and new eco-friendly raw materials. The aim of innovation is to improve the living conditions or the quality of life, especially in the developing countries. Technological innovations in these countries stand a good chance if they are generated from within their own environment. Towards this, many countries have started looking into their traditional practices with the aim to innovate them to suit the modern needs. These innovative practices, besides being environmentally sustainable, generate employment among the rural youth, thereby improving their quality of life. Point 2, Innovation and Industry. Development in the industrialized countries is based on high productivity, which in turn is based on technology. Production technology is a method of combining 5 Ms: the industrial technology or the elite system or the elite stream use high inputs in the form of technology M1, materials and manpower M2, and capital investment M3. The management system M4 is hierarchical where worker participation in the decision making process varies. The standardized finished products have markets is spread over large, sometimes global markets M5. The developing countries, on the other hand, have chiefly artisanal technologies or subaltern subaltern technologies. These technologies use simple tools, locally available raw materials, minimum investments, and small local markets. The management is done by the family, and the manpower usually comprises of the family members. Conventional indigenous technologies have limited knowledge of the technical know-how M1, material resources M2, and money M3, and therefore remain confined to limited markets M5. Innovation in the various steps of the production process is conventional technologies is therefore essential. After the Rio Declaration on enriching biodiversity and Copenhagen Declaration on enriching social and cultural diversity, the trends of industrial manufacturing are shifting from ordered and standardized products and processes towards sustainable, holistic, and more flexible processes. This concept is rooted in the cultural diversity of the concerned countries. Therefore, there is a need for the synergy between the elite and subaltern systems of science and technology that would lead to sustainable development, especially in the developing countries. The Gandhian approach involving the small scale industries in the village setup is now seen as an important model of rural sustainable development. Gandhi had appealed to the Indian scientists to pursue research and seek solutions to the problems of development of India within the human and material resources of the village. With the advent of new technologies like biotechnology, information and communication technology, ICT, and new raw materials developed by material science engineering, a new small scale industrial strategy is envisaged that will provide enhanced opportunities for rural industrialization. A synergy A synergistic approach of the industrialized and artisanal production technologies can give rise to innovative technologies as given in the following table. In India, the new innovative technology based on microprocessor control systems is used in several areas like leather, fruit processing, pottery, and ceramic and metal ware industries. For example, in Himachal Pradesh, the fruit growers have adopted the innovative method of processing fruits or vegetables where they use low cost automated tools that can be handled by unskilled operators, process a range of products instead of a single product, and employ software operated sensor cards to reduce wastage. The processing plant consumes least power as it uses human labor for cutting and crushing fruits, crushing fruits or vegetables. Since the processing plant operates in the area where the fruits and vegetables are grown, the transport of raw material and had energy consumption and pollution associated with it is highly reduced. This also reduces the migration of the local population to urban areas. Table: a comparison of industrial, artisanal, and innovative technologies. Technology components: M1 machines, industrial, high cost machines, know how based on physical or chemical processes. Artisanal, tools, jigs and fixtures, traditional process, physical and chemical. New innovative, small machines using informatics and flexible manufacturing, biochemicals, and a variety of new physical and chemical processes. Technology components M2 materials, industrial, metals, minerals, chemicals, and petroleum products, high energy requirements. Artisanal, local, or traditionally used natural materials and human or animal power. New, innovative, locally available materials including hitherto unused biomass produced through biotechnology, low energy requirements. Technology components M3 money, industrial large investment with high capital labor ratio. Artisanal small industries. New innovatives, capital or labor ratios less than those in industrial technologies. M4 management. Industrial in industrial factories and hierarchical management structure. Artisanal family unit. New innovative small production units, family size units, and less hierarchical than industrial technologies. M5 markets, standardized products transported to spread out markets, traditional products and local markets. It's standardized and customized products, both small and large markets, is the new and innovative. Several initiatives have been taken by the government and non-governmental organizations (NGOs) towards launching innovative programs to connect the science and technology (S&T) organizations with communities in rural and semi-urban areas. These NGOs work in all fields from education, health, environment, and women empowerment to the design of appropriate technological solutions. Technological solutions. The Indian Institute of Science at Bangalore established a Center for Application of Science and Technology to Rural Areas ASTRA, which has been working on projects in areas like low cost buildings, fuel efficient stoves and crop dryers, water purification, renewable energy, etc., among which the most notable is the rain water harvesting technology. The scientific organizations of Government of India like the Department of Science and Technology (DST) and Department of Biotechnology (DBT) have also initiated programs towards funding the agencies organizations working for rural development. The Council of Scientific and Industrial Research (CSIR) has developed many technologies which have the potential to generate employment and improving the quality of life. Some technologies developed by CSIR broadly are post-harvest technologies, cultivation and processing of medicinal and atomic and aromatic plants, food technologies, drinking water, health and sanitation, low-cost housing, leather and animal waste utilization, upgradation of skills of rural artisans, and technologies for other small-scale industries. The recognition that there is a need for the merging of the elite and subaltern streams at the higher levels of the government has resulted in the technology missions and the recent formation of the National Innovation Foundation (NIF). Technology missions encompass different agencies, public and scientists who work together to cover the entire chain from research and development to delivery. Six technology missions were launched targeting the rural areas. The NIF works with the NGOs and high-profile laboratories to cover the entire network from science and technology to documentation, dissemination, and information technology, value addition and product development, business development, and micro ventures to management of intellectual property rights. According to the chairman of NIF, Dr. R.A. Maselkar, NIF has been set up to give expression to 94% population which has been neglected so far. They comprise artisans, tribals, farmers, the unemployed, the illiterate, and the youth. In order to survive and succeed, they keep on innovating. The challenge is to connect the 6% that is exposed to modern science and innovates in a formal way to the 94%. Next audio number 22, we will do in that audio left of the topic, that is recycling and reuse of unit 15, and further of the topic of sustainable development.